All right, I think we're gonna go ahead and get started. So I'm Kevin, and this is gonna be about networking, as Daniel just introduced. So if you have any questions about, or like while I'm going on about this, you can just yell it out, it doesn't really matter. If something doesn't make sense, just ask, I'll try to explain it better if I can. Hopefully I can. So yeah, it's pretty informal. So to start off, we're gonna talk about the OSI model, which is kind of how we model what goes on when we're using a network and how data goes from one place to another. So we're gonna start off at the bottom and the physical layer, which is kind of the media or the binary transmission of all the data. So that'll be something like plugging in an Ethernet cord or something like that, the low level of how things get connected. Moving up, there's the data layer, and that's more of like the MAC addresses, so it knows which device is which and things like that. And those two are kind of both the main low level layers in this. And moving up the network layer is about IP addresses, and maybe routing will be involved in there, and it'll know how to send something from one machine to another after it knows what it is. Going up even further, there's the transport layer, which is the end-to-end connections, as we can see from there. Moving up, these are the top three are kind of the application layers, or for the actual user. So it'll be inter-host communication for session. Presentation layer is data representation and encryption, and the application layer is network process to application. So the top three are more kind of what happens once the data gets sent and is received at the end. So there's two main models. That was the OSI model. Another one is the TCPIP, which, as you can see, is more simple and has less layers. So the bottom two are condensed into one called the host to network layer, which are the low level ones, as I explained. You can group those together. And then there's the internet, which is similar to the network layer, and the transport is the same in both. And then the top three are kind of the high level that are condensed into one for the TCP/IP model. All right, so MAC address, what it is the media access control. It has nothing to do with Apple computers. And it's assigned to every network adapter, so it's kind of its unique name on the local network, so it's only used on local, and it's kind of the specific name. This is what one will look like, something like that. There's 12 hex values, which means that there's up to 48 bits, meaning that there's 2 to the 48th, or whatever that number is, 281 trillion, I think. Yeah, billion. So there's a bunch of them, so that basically there's no conflict of having the same name in the same network, which could become a problem. It's used to switch, or used by switches to direct traffic to physical ports so that the data can go to the correct places. And it can also be changed or spoofed as needed. If you ever need to change it, you can go ahead and do that for the specific adapter. All right, another is the Internet Protocol address, or the IP address, which some of you may be familiar with. And this is how things communicate across the internet. So whereas the other one was only on local, this one goes across networks. And this is done by routing, which we'll get into a little bit later in routing tables. These have to be unique on a local network so that the data doesn't get mixed up, in that, because when it goes to some place, it has to know where the final address is. And if two have the same one, it wouldn't know which one to send it to, so the data would get messed up as it's being sent around. There's private ranges, which can be used repeatedly, as we'll see in a slide or two. So those can be repeated across different networks because they're private. And there's also public ones, which we'll talk about later. And a single adapter can also have more than one IP address assigned to it. So IPv4, which you can see in the top right, is kind of the one that's the standard now still, and it's running out, but it hasn't run out yet. So there's IPv6, which is just larger. As you can see, you can have more values. That's in hex, as it says. That one's not as widely used yet because it's not needed, but eventually, as we run out of IP addresses for all of our devices, all the networks, we'll have to move into that one, but that's still down the road. Is there any questions so far about anything I covered? All right, cool. So net masks pretty much essentially says how many hosts you can have on a network. So as you can see, if it's /32, each of those values is 32 bits, because it's 256 for each one, which is 2 to the 8th, and then there's 4 of them, so 32. That means that there's kind of 32 that are already like assigned or not available, meaning that there's only one host possible in those. So that one's not as, you won't see that one as much. You'll see the other 3 much more commonly, and it can also be any number. So for example, -24 would be 255, 255, 2550, because the last one's 0, could go anywhere from 0 to 255, which is the other 8. Similarly, -16 is 255.255.0.0, and -8 is 255.0.0.0. So the more that you can change, the more hosts you can have. And then you're also going to need to have, or you subtract 2 for the actual number of hosts you can have, because you always need to have one for broadcast and one for the network. So anything, if you do whatever it would be, you subtract 2 in the end, and that's how many hosts you can have on that network. There's a couple examples if that didn't make perfect sense. So this first one is one of Iowa State's internal networks. So it's 10.001 and then 10 to 255, 255, 254. So that kind of shows how it's similar to the 255.0.0.0 because the last 3 values are the ones that are changing. So it's a /8, meaning that there's that many hosts. And the reason that it starts at 1 and ends at 254 is because 10.0.0.0 is for the network, and 10.255, 255, 255 is for the broadcast host. Sorry. Okay. Another one, this is a public range, and that's 129.186.0.1 and goes up to 129.186.255.254. So the last 2 are the only ones that are changing, so it's a /16 or 255.255.0.0. So there's less hosts available on this one. And similarly, the 129.186.0.0 is reserved for the network, and 129.186.255.255 is reserved for the broadcast host. So I mentioned a little bit ago, there's private and public ones. So there's specific ranges that are set aside just for private use, which makes it more convenient. You don't have to worry about having ones overlap. And these can be repeated, as I said, on different networks. So one of them is 10.0.0.0, and that's /8, which if we go back one, that's the Iowa State's internal network. It's pretty much the same thing as that. Another one is 172.1.6.0.0, and that's the 12. Another one is 192.168.0.0, which is what some of you are probably familiar with. If you have a home network, that's pretty common there. Your router could be on like 192.168, like 2.1 or something around there. So if you mess around with any of that stuff, you've seen that at some point. What's kind of confusing, the last one, 192.168, is really similar to Iowa State's public one on the previous slide, which is 129 instead of 192, and then 186 instead of 168, so the last 2 are just flipped. But they're different, and it can be kind of confusing sometimes if you're looking at them. Another thing that we mentioned a little bit ago was routing. So this is how things get from one place to the other. So let's say, for example, you're starting on PC 0 over there on the left, and you want to send something to, say, server 1. There's going to be routing tables on the actual device that's going to figure out where it needs to go. So it'll look at the final address where it has to end up, and it's going to see that it doesn't know where that is. So it's just going to kind of send it up a tree. If you think of it like that, it's going to keep going up until it knows, or one of the devices knows where it should go. So that one would go to the switch, and it still wouldn't know where to go, so it would send it up to the top left at router 0. It still wouldn't know, so it would send it to router 1, and it would see that that's one of the ranges underneath it. So it would send it down to switch 1, which would then say, I know exactly where that is, and send it to server 1. So that's how routing tables are set up. It just kind of goes around and figures out where it needs to go, so it goes up and then back down. There's some more examples on the next one. Yeah, so similar to that, if we're on PC 0, which is that left one again, and we want to go to the 172.18.0.0, which is in the middle branch or section. To get there, it's going to need to first send it to router 0 because it doesn't know exactly where that is. It's going to send it up. Similarly, if it's going to this right branch, 172.20, it's going to have to send it up to router 0 to start off as well because it doesn't know where it is. And then from there, the difference between those two is it would go to router 1 and then go down, versus it wouldn't know where it is and it could go to router 2. So that's where those would vary. And then if it's staying on there in the 172.16, which is that left branch, it's going to know where that is, so we can call that on link, or as in it knows where it is, and it doesn't have to send it up to router 0. If we start up at router 0 for this right side, and it wants to go to 172.18, which is the middle section again, it's going to need to send it to router 1 first so they can get there. And again, if it wants to go to the right branch, it's going to need to send it to router 1 as well. But if it wants to go to 172.16, which is below it, it knows where that is, so we can call it on link again. And also up in the top left is 172.17, and it knows where that is as well, so we can call that on link. The NAT type, or the network address translation, is something that's pretty useful because it allows, it's this kind of NAT router in the middle, it allows you to have the IP address that's visible from the outside or where things are being sent from. It can just put it there, and the NAT router will figure out where it needs to go on the internal network or what's inside this box. So you can have one address and then it breaks into multiple different devices on the inside, which is convenient and helps you not have to go through a whole bunch of IP addresses just for one, or for each computer, when you can just have it be as one and then split it from there. And the NAT router is smart enough that it can keep track of various sessions and things like that, so that it knows that once it gets to the NAT router, it can send it to the appropriate computer on the inside, because it keeps track of the various sessions, and it knows, like if you send something to Google and it goes out, it knows when it comes back that it needs to go back to the inside one or wherever it came from initially. So that's something that's also nice. Some common protocols that you'll see, back to the OSI model at the beginning. In the network layer, there's IPv4 and IPv6, which I talked about a little bit ago. IPv4 is the one that's mainly used still. Another one is ICMP, which is used for errors and status messages between devices. The transport layer, which is another layer from the OSI model, that has mainly TCP and UDP, which you may have heard of. TCP is connection oriented, meaning that it waits to make sure that a packet or whatever it sends there is received by the user, whoever is requesting it, before it sends the next one. Whereas in UDP, it's connectionless, meaning it just keeps sending them, and if it doesn't get picked up at the end, it just kind of skips over it and keeps getting the next ones and just keeps sending them. It doesn't wait to make sure it gets it. So that would be something like a stream, or if you use FaceTime and it gets like blurry all of a sudden and you don't know why, or if you lose signal for a little bit and it goes blurry, it's because it's losing the packets and it doesn't know what to do, so it just makes it pixelated and blurry because it doesn't know what should go there, but it just keeps going over it. It doesn't wait. On the application layer, DNS, which a former member, Matt Gerst, said it's like the address book of the internet. That pretty much means when you type in something like google.com, it has to get translated into an IP address to know where to actually send it. So DNS is what keeps track of what all the various names are. So anytime you type in like a URL, it's going to get rerouted to an actual IP address through DNS. HTTP is one that you've probably seen also. That's what a lot of websites use in web browsers. FTP is File Transfer Protocol, which is another pretty common one. SSH is if you need to take, or on a remote computer, get a shell. So like from my computer, if I want to go somewhere else and get a shell, I can SSH into it and get a secured shell on the other one. SMTP is used for email, and IRC is Internet Relay Chat, which you probably won't use in the future. Are there any questions about any of that stuff? All right, so the next ones are some basic utilities that you can use in Linux if you're ever configuring a network or need to figure out if something's working, or just anything about networking in Linux really. The best thing to do about these is to read the man pages, because it'll give you a lot of the switches that can be really useful. So there's a couple included here for switches, but if you really want to do something specific or need to know how it works, reading the man pages is probably the best thing to do. And I'll demonstrate a few of them so you can see what it looks like. So ifconfig is used to display information about all the different adapters on, or interfaces on your device. So I'm just going to go into this guy real quick. So if we do ifconfig, we can see that there's, is that big enough? I can try and make it bigger. Hold on. Actually, I have to get out of it. Can you guys read that okay? That's up there a little bit. I'll make it bigger. Okay, hold on.
The colors are kind of weird.
Is it?
That's the main issue.
Oh, okay. Let me try going in here. This might be better. Oh, it's so slow. Is that better? You can see it? Okay, we'll use this one instead. So as you can see, something just fell. As you can see in this, there's two different interfaces here, ENP0S3 and LO, or the local one. So you can see various information about that. I think it has the NAT type in there, which you can see, the broadcast channel and the the host one, which we talked about earlier, which is 10.0.2.15 for the first one. So you can get various information by running this about the different ones on here. Actually, it's coming up later. We'll get to it then. Route is a thing that shows the routing table for your computer. So if I type in route, we can see what it's going to do, or like where things are going to be routed to depending on where you're trying to send it. One of the switches for this that's kind of useful sometimes is -n. And so instead of saying like default, it's going to put the zeros, or instead of a star. Or if it like has a different name for it and you put -n, it's going to give you the actual address of it, and it won't just be the name, which can be more clear sometimes if you need that. So that can be helpful if you're trying to figure out where things are going to go. And you can also manipulate the route, the things you're going to do, and like add to it and delete things and whatever you need to do to configure it properly. IP route 2 is used for also configuring interfaces, addresses, routes, and more. And it kind of replaces the first two that I showed you. I'm not going to demonstrate that. I don't think it's on there. IF up and IF down is used to like take things up and down or turn them on and off in a sense. So say I'm back on this one. I run if config, and I want to turn off the LO one. I can do down LO. Permission 9. Okay. Okay. And then if I run it again, we can see that it's not there because I took it down. And then if I want to put it back up, and then run it again, it should be there. Yeah, then they're both back up. So that can be useful if you ever need to like turn things on or off and go up or down. Another one is Netcat, or just NC. And this is good for reading and writing data across the network if you need to do that. And it can use TCP or UDP. So I could just demonstrate like this first one. If you want to listen on, if you want to listen on port 8080, you can just do NC-L and then 8080, which nothing's really going to happen, but we can do it anyway. So it's just going to sit there and it's listening for anything to come through, but obviously nothing's going to come, so we can just stop it. But that can be useful, and there's a whole bunch of other switches you can do that you can see on here. This one's good if you like read the man pages and need to know what to do. That'll help you out a lot. Dig, NS lookup, and host are all to perform DNS queries. So we can do dig and then google.com. So that's going to show the actual address of the Google server that you're going to, which can be helpful. You can do another one like, I don't know, you could do iState. I think. Yeah, so like this one here in the middle, which is part of that range that we saw earlier, the 129.186, in there is where that's at. And there's some other, there's some other information in there too. NS lookup does a similar thing. It pretty much shows the same information, it's just a little bit different. And the last one, which was host, is probably, I don't know, it's a little bit more helpful and it's more clear. So if we do host, istate.edu, it just gives you the three. It has the address, the IPv6 address, and also how mail is handled in there too. So all three of those kind of do a similar thing, and I don't know, whichever one you want to do should be able to help you, but some of them can be better at other things than others. Ping and Traceroute are also really good for testing to see if you're actually connected to a network, or if you can figure to trace where routes are going or where something's actually going when you send it. So if you just do ping google.com, this is a good test to see if you're actually connected to the internet. And you can see that it's going through and coming back, so it is connected. So the other one, Traceroute, is good for showing where all your information is going, or the stuff you're sending on the way. So we can trace route. Okay, that one's not there. We can try that one in this. Hold on real quick. Hopefully I typed that correctly. I think I can just... can you see that okay? Is it still the color's bad? We can try real quick. So this would be, if you run Traceroute, it would be like this bottom section here. You can just see where it's going through the various levels through like the routing table. Or if you had to figure out what's actually happening, that's useful for that. Stop that. Yeah, so that's Traceroute. And then Netcat is good for displaying network connections and seeing what's actually happening at the current time. So this one has a lot of switches. As you can see here, there's a couple examples. If you do this netstat NATP, you get, as you can see, what's like what they stand for, the numeric statistics of all active TCP connections and the process that owns the connection. So that one's like pretty specific, and you can see exactly what you need. So if you just do, if you just do netstat, if you just run netstat, it can be like a bunch of information, and it's not really helpful because it's too much. You don't know what to look for at first. But if you do something like netstat -ncap, I think that's correct. Go to the top. Is that right? NetP. Hold on. There's so many. What was it? NATP. Okay, that one's a little better. It just shows the one that has TCP. Sorry about that. And it says like the state, the local address, what it actually is. So this one's TCP, which is what we specify, which makes sense that it's showing that one. So it can be, you can use this to make it more specific and figure out exactly what you want using the switches, which is helpful. And again, reading the man pages is how you can find out more exactly what you need there. So that's pretty much it for the beginners night. If you want to learn more about this stuff, there's a past presentation about Intro to Network Security, which is really useful because it gets more into the security aspect of networking. There's also a lot of courses here at Iowa State you can take. Something like Computery 230, which is about cybersecurity concepts. I think 231 also has a little bit about networking in there. And then Computery 49 is about networking and data communications. 530, which I believe is also 430, is one that a lot of people enjoy. I know I haven't taken it, but it's about network protocols and security. I think that one's pretty enjoyable from what I've heard about it. And 541 is another one if you've taken those, or you want to take another one, which is high performance communication networks. One more that isn't on there, I took Computer Science 252, which it was like an online class, and it's Intro to Linux. And there's like 2 or 3 lectures about networking. That's kind of a good introduction and overview about how it works in Linux. So any of those would be good to take. And then this presentation, along with that other one there, it's a link, but you can also just go into the past presentations, which I believe Keen linked yesterday or a couple days ago on Slack. You can just go in there and look at any of the old presentations or other presentations whenever you'd like. So that was it for this one. Are there any questions about anything that I went over today or anything in general? All right, well, I think that's about it then. Thank you.